Hello, this is the first in a three-part series about finding the zeros of a polynomial function. It's chapter 2.5 in the textbook that RVCC is using in the fall of 2020, and this video pertains to the rational zero theorem. So the rational zero theorem purely provides us a set of numbers that could contain the rational zeros. So the rational zeros have to belong to that set, but it limits the scope of the number of, it helps us focus where we're looking for the rational zeros. So f of x is a polynomial. It has to have integer coefficients. And we're going to look at the constant term and the leading coefficient. So p is going to be all the factors of the constant term, and q is going to be all the factors of the leading coefficient. And then the possible rational zeros are any of p divided by q. So if we look at this example here, we have x cubed plus 2x squared plus minus 5x minus 6. We're going to ignore everything in the middle. We have a leading coefficient out here that's 1, and we have our constant, which is negative 6. Okay, so all of the possible factors of negative 6, this is going to be our p numbers. And 6, we can get to 6 by 1 and 6. And this can be plus 1 and minus 6, or minus 1 and plus 6. So we have plus or minus 1, plus or minus 6. Or we can do 2 and 3. And again, this can be plus 2 minus 3 or minus 2 plus 3. So we're going to have plus and minus of each of these. If we take a look at 1, the only way we can get 1 is if it's 1 times 1 or negative 1 times 1. So that's just plus or minus 1. So now this is, and this is our q. So our p over q is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. This is our p divided by q, which is plus or minus 1. So in this case, when our leading coefficient is just 1, then we just have all of the factors of our constant. So our possible rational zeros just become plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? So these are our possible zeros. So again, it doesn't tell us what they are. It just gives us a smaller set of numbers to look for our zeros within. We're going to take a look at another example where our leading coefficient is not a 1. So here, again, we're just going to be looking, we have 4x to the 5th plus 12x to the 4th minus x minus 3. And for our rational zero theorem, we don't really care what's in between. We don't care that there's not an x squared. We're just looking at our leading coefficient, which is 4, and our constant, which is negative 3. So we want to take a look at the factors of 4. We can get 4 by 1 and 4, or we can get 4 by 2 times 2. So these are all going to be plus or minus. And we can get 3. The only way you can get 3 is 1 times 3. So 1 and 3 are all of our factors of 3. So it's always going to be the constant term divided by the leading coefficient. So we have plus or minus 1 plus or minus 3 divided by plus or minus 1 plus or minus 2 plus or minus 4. So these are our possibilities. So I always like to choose each number in my denominator and put each. So I focus on one number in my denominator, and I put each of my numerators divided by that number. So I have 1 over 1. Again, this is going to be plus or minus. We have 3 over 1, and this is going to be plus or minus. So this is plus or minus 1, plus or minus 3. And now I look at my next number of my denominator. We'll focus on, here, we'll do this. We'll focus on 2. So we have plus or minus 1 over 2 and plus or minus 3 over 2. And then we take a look at 4. And from 4, we have plus or minus 1 over 4 and plus or minus 3 over 4. Okay, so this is the set of numbers where we can look for our zero, our rational zeros. So square roots, imaginary numbers, they aren't going to be included in here. But our rational zeros will be one of those numbers. Okay. There will be another video of actually going through the process of finding the zeros, but this is just finding the set of the potential rational zeros.